In this video, I'll go over the solutions to the take-home problems number 8 handout. For the first question, we're asked to find the intercepts and the slope of the linear equation y equals 4x minus 12. So we're being asked for three things here. We're being asked for the slope, we're being asked for the x-intercept, and that's the point where the line crosses the x-axis, and we're also being asked for the y-intercept, which is the place where the line crosses the y-axis. Now this line, y equals 4x minus 12, this is in a nice form. This is in slope-intercept form. And what makes this so nice is that the slope is simply the coefficient of x, and the intercept is the constant term. This constant is the y-intercept. So that means that the slope is 4. And the y-intercept, sometimes we refer to the y-intercept as simply the number negative 12, but often we'll be asked for of the point where the line crosses the y-axis. And so that would be the point 0, negative 12. And the only thing that's not immediately easy to read off of this equation is the x-intercept. And the x-intercept is the place where we cross the x-axis. Now the x-axis is where y equals 0. So the x-intercept is always going to look like something, 0. So how do we figure out what that something is? Well, if we know that y is 0, we can replace the y in our equation by 0 and solve for x. So if I add 12 to both sides, divide both sides by 4, I get x equals 3. And that means that my x-intercept is positive 3, 0. So those are my answers. Now we're going to do the same thing again, but with this equation, 5x plus 2y equals negative 20. The downside of this equation is that this is not in slope-intercept form, and so we're going to have to do a little bit of work to answer all three of those questions. So again, we're being asked for the slope, we're being asked for the x-intercept, and we're being asked for the y-intercept. Now for the slope, the easiest thing to do here is rewrite this equation in slope-intercept form. So we're going to solve this equation for y. So we've got 5x plus 2y equals negative 20. So let's subtract 5x from both sides. Divide both sides by 2. So that's the same as multiplying by 1/2. And if I distribute that 1/2, I get negative 5 over 2x, and then half of 20 is 10. So there's my line written in slope-intercept form, and now, just like the previous problem, we can read off two of the answers of these questions, which is that the slope is negative 5 over 2, and that the y-intercept, again, typically we'll write this as a point, is the point 0, negative 10. And it's only the x-intercept where we have to do a little bit more work. So remember, again, we can set y equal to 0 and solve for the x-intercept. But I'm going to do that with the original equation. It's actually a little bit easier to do it with the original equation, because there's a little bit less algebra to do. So if I replace y with 0, that just gives me 5x on the left-hand side equals negative 20. Divide both sides by 5, and I get x equals negative 4. Now I could have done that by substituting y equals 0 in my slope-intercept form down here, but it's a little bit easier, as I said, to do it with the original equation in this case. So that means that my x-intercept is the point negative 4, 0. And there's the solution. For this one, we're asked to find the slope of the line that connects 2 points. And so what we have to do is remember the formula for slope, which is that m equals y2 minus y1 divided by x2 minus x1. The difference in the y-coordinates divided by the difference in the x-coordinates, which is the same formula that we had for average rate of change. Now the order that I label the points doesn't matter as long as I'm consistent. So I'm going to call this first point, 2, negative 5, I'm going to call that my x1, y1, and my second point, negative 3, 7, I'm going to call that my x2, y2. So with those labels in place, I've got 7 minus negative 5 divided by negative 3 minus 2. On the top, 7 minus 5, that's 7 plus 5, that's 12. And on the bottom, I have negative 3 minus 2, that's 12 over negative 5, which we would typically write as negative 12/5. And that's my slope. All right, here we have a word problem, and I know that the word problems can be a little bit overwhelming sometimes, so let's try to break this down. So the first sentence here just tells us that we've got two quantities that we're talking about, which are gas mileage in miles per gallon and horsepower. Those are the two variables in this problem, gas mileage and horsepower. And then only the rest of the sentence is telling us that there's a linear relationship. So all that does is set the stage. That means we're talking about a line in this problem. We're talking about a linear equation in this problem. And the two variables are gas mileage and horsepower. That's all that's going on in the first sentence. Just kind of sets the stage. Now the next two sentences give us two data points. So let's skip those for the moment. And then we say we want to find the slope of the linear relationship between gas mileage and horsepower. So we know we're trying to find a slope. So looking back at those two sentences that we skipped, those two data points are going to give us my x1, y1 and my x2, y2. So we know that to calculate slope, we need to find y2 minus y1 divided by x2 minus x1. So now the only question is, which variable is the x variable and which variable is the y variable? Am I putting horsepower numbers on the top, or am I putting the horsepower numbers on the bottom? And the mileage, does that mileage go on the top or does the mileage go on the bottom? And the key word in this entire word problem is this word right here, depends. It says the gas mileage depends on the horsepower. And that means that the gas mileage is the y value and the horsepower is the x value. The gas mileage is the output of the function. The horsepower is the input of the function. Y always depends on x. So whenever you're reading a problem like this and you know that one variable depends on the other variable, the one that's doing the depending is the y. And the one that's being depended on, that's the x. So now when I look back at my two data points, the first one tells me about a compact car that has 158 horsepower and 35 miles per gallon. Well, the horsepower, that's the x, so that goes on the bottom of my fraction. And the mileage, that's the y, so that goes on the top of my fraction. Second variable is my pickup truck. So my pickup truck has 282 horsepower, that goes on the bottom of my fraction. And 19 miles per gallon, that goes on the top of my fraction. So now all we have left to do is some arithmetic. So on the bottom, 282 minus 158, that works out to be 124. On the top, 19 minus 35, that's negative 16. We can reduce this fraction, so we do so. The top and bottom are both even numbers, so we can divide by 2. That gives us negative 8 divided by 62. They're still even on the top and the bottom, so I divide by 2 again. That gives me negative 4 divided by 31. And that's the slope of the relationship. All right, last question here has us doing some matching. So we've got 6 different slopes, one of which is undefined, and then we've got 6 lines, and we're trying to match the slope with the line. So let's just go through these one by one. So for number 1 here, Roman numeral 1, the slope is 1. And so what that means is that the change in y divided by the change in x is 1. And or in other words, the rise over the run is 1. The rise and the run are equal. So we're looking for a line that, as I go between 2 points, the rise versus the run is the same. And that line is C, because if I pick 2 points, and I think about the run versus the rise, we can see that the run here and the rise are approximately equal. And no other line here does that work out, where the rise and the run are the same. And so C goes with 1. If we look at Roman numeral 2, again, that 2, that slope, represents the rise over the run. So here we're saying that the rise is twice as big as the run. And the line we're looking for here is D. Because again, if I pick 2 points, think about the run versus the rise. Here we can see that the rise is much larger than the run. And if we look at any of other lines, none of the other lines make that happen, where the rise is so much bigger than the run. So 2 goes with D. For 3, we've got a negative slope. So remember, all that means is that the rise and the run go in opposite directions. So if we go from left to right, where the rise is positive, where the run is positive, we go from left to right, the run is positive, then the rise would be negative, which means the line is going down. We've got 2 lines with negative slope. A has negative slope, where as I go from left to right, the run is positive, but the rise is negative. And F also has negative slope, where again, as I go from left to right, my line goes down. So which one does Roman numeral 3 go with? Well, all we've talked about is the negative sign. What about the actual number? Well, negative 1 means that the rise and the run are the same size. It's just that they have opposite signs. And the line that goes with that is line F. Because again, the rise here, even though it's a negative rise, and the run are about the same size. The two legs of that triangle are about the same length. And that's what we're looking for the slope to be -1. And that means we're looking for letter F. And then for Roman numeral 4, the only other line that we saw here that had a negative slope, that was A. But again, let's just think about what this means. So if rise over run is -1/2, we've talked about what the negative sign means. That just means the line goes down as you go from left to right. The 1/2 means that the run is twice as big as the rise. The bottom of the fraction is twice as big as the top of the fraction. And we're seeing that here. The rise here is small, and the run is twice as big. And that's where we're going to get a slope of -1/2. So Roman numeral 4 goes with A. Roman numeral 5, we have 0 slope. So again, slope is rise over run. So if that fraction equals 0, the only way a fraction can equal 0 is if the top of the fraction equals 0, which means that the rise equals 0. So if I go between 2 points, and the line we're looking at here is B, there's no rise at all. The y value stays the same. And so B goes with Roman numeral 5. And then finally, undefined slope. Well, again, one more time, slope is rise over run. And the only way a fraction is undefined is if the bottom of the fraction equals 0. The top of the fraction equaling 0, that just gives me a 0. The bottom of the fraction equaling 0, that means I'm undefined, which means we're looking for a line where the run is 0. In other words, where the x value never changes. And that's line E here. If I go between 2 points, the x value stays the same, and so that's an undefined slope. And so we're looking at letter E. So a little bit of a process of elimination, thinking about positive slopes versus negative slopes, but as you see in every single one of these, we thought about slope is rise over run, so what does that number tell me? And that's the way you want to approach these types of problems.